Welcome, one and all. This is Ed Bujak. We are in InnovatiCS, and this is our third 1-hour session on Python. So it's Python generics, I guess, or not there's no such thing, but general Python. So it's nothing advanced, but things you need to know in all programming languages. In this case, it's Python. So a quick review of our previous session is looking at all different kind of data types and built-in data types that Python provides and what you can do with them and why. Certain data types are numeric. Certain data types are like a bunch of data, other data types. So the big concept in when you have a bunch of them is there order or not? Is it immutable or not? Can you change the values or not? So it's mutable or immutable. Certain data types you can only have, like sets. You can only have, each element can only be represented once in that set, like in a mathematical way. That's what happens in math. So we talked a little bit also about dictionaries. So let's get into, that's not the exhaustive we didn't talk about exhaustively all the data types in Python. Some of the other ones are kind of esoteric or exotic, so you'll see them rarely. So we definitely hit the highlights. Now, so we'll just talk dictionary, a reminder, because it's real important. Dictionary is the order is not okay. So it's what it's referred to as a collection. The order is not preserved. If it looks like it's sorted alphanumerically, it's a pure accident or pure coincidence, I should say. The delimiters are curly braces. The elements are not single elements; they're pairs. So, and further, it's nice to give them a name. It's a key value pair, and colon is between them. It's not stored that way, but visually and conceptually stored that way. So they're associated. So you say, there's a key called name. What's the value associated with the key called name? Hey, there's a key called weight. What's the value associated with that key called weight? Now, you can't have more than one weight, so the keys have to be unique. But you can also change. Dictionary values are immutable. Now, not all keys are possible. So there's this other concept of is it hashable, and there's different terms for it, but not everything can be hashed. Hashing is done for efficiency, for mostly retrieval. It's insanely fast retrieval if your data is hashed. Keys are hashed because also with sets, those elements, or in dictionary case, the key is hashed. Well, what's that get you? Insanely fast retrieval. So most of the action in Python, I'll say, behind the scenes, is done with dictionaries. But also, if you're dealing with data science, machine learning, a lot of the stuff will be encoded as, not encoded, but it can be readable. But it's nice to have numbers, but what do those numbers mean? And it'll say, oh, this is the p-value. Here's the number. This is the statistic that you asked for, and here's its value. So they don't just give you, here's 5 numbers. It's like, which one's which and where. I got to no, it just, here's a dictionary, key value pairs. Readable. So it's nice. So dictionaries are everywhere. Really honest. So we just did a little example where we just get personal information, and this is what we had before. I think it was a string and an age and a height and a weight. Oh, in imperial units. So the 60 is 5 feet, right? 60 inches. So here we go. Personal information dict. Okay, we're going to create a dictionary. Okay, great. So they occur in key value pairs, and this doesn't have to be this way. This is just formatted nicely. So a lot of people do this, especially if you have a lot of entries. You can put this all in one line. It gets a little hard for humans to parse out that stuff. If you put in one per line, it makes life easy. And I could comment on this weird stuff. Like I could put a comment out here and say, "Beware." Wait. My 3 key's not working. Oh. You can hear me hitting it. Is there a comment? No. I cheated. Sorry. I can say, if there's something crazy going on, I can put a comment out there and it still runs. So remember, the comment is, this is referred to as a line comment, but more specifically, it's anything after the pound symbol to the end of the line is ignored. So it's like, is this a line comment? Well, it's only on one line, but it's kind of a partial line. But it's called a line comment, so this is nice. So this is done often, putting one per line to make life real easy. And people, most of the time, don't go through the trouble of doing this. Uh-oh, wrong key. Unless you feel like it. Great. Okay. Okay. And do you feel like putting spaces here? There are standards, and this is, but this is a dictionary, so you probably won't see it this way. But this is just for reading purposes. And can you, well, right, sure. And this is what it looks like. Key value pairs. Remember, and then we looked at, can you index it? No, it has no order. So you can't say, give me the 0th element. Well, give me the 0th key value pair. You can't do it. Okay, well, it's not, it's a question that has no answer. It's a question that's like not, it has no answer. Anyway, so can you look at you say, hey, whatever that variable is, can you look at the keys? Sure. Only the keys. Great. Can I only look at the values? Sure. Great. Remember, this is when you can see the association a little differently now. So if I came in with a list of these things and then a list of these things, I could say, hey, make a dictionary of those two. And we basically pulled apart the dictionary. So give me the keys, give me the values. But when you want to put them together, you'll use a thing called zip. Just like a zipper. I got a bunch of little rungs here with different names, different keys and different values, and I put them together like this. And it's called a zip. It's great, like a zipper. So we're going to look at conditionals. And conditions are things, it's a condition, okay? And they'll usually work on these things called relational operators. So there's truckloads of these operator things, and other than theory, it's nice to see it when you need it. So relational operators. Operators. And they're things like less than or equal to, greater than, no order, greater than or equal to, not equal to. That's it. Great. Now, conditionals, they want a Boolean. So when you ask the conditional, the only answers are yes or no. But programming, it's true or false. Okay. So you say, is A greater than 5? The answer is yes or no, or true or false. So you want whatever your question is to resolve to a Boolean. Okay? So relational, yeah, you can say, well, greater than this, yeah, that's I can relate to that, but well, no pun intended. So the relational operators, but there are other ones. You can do membership. The membership operator, which is big. I'll try to emphasize that a bit, and it's called in. You know, is this variable in this thing? And yeah, it's like the club. Are you in the club or not? Oh, yes or no. I don't feel like saying, you know, is Ed in this fraternity list of 100 fraternity names? I'm going to say, is Ed part of Alpha Omega? Or is Ed part of, you know, Delta Psi? Or is Ed part of Kappa Sig? Or is Ed part of... There's 100 of them. Or it could be infinite amount. So you just got to say, is Ed in? And it says yes or no. So let me pause, folks, if I can get here.
Do we also have something not in, if we need to check that?
You can also do nots. Now, you can do the not of the not equal, which is crazy. You know, that's like double negatives. It makes you have to stop and think, right? Try not to do that. Don't do double negatives, kind of thing. But, you know, you can also do not in. Very, very good. So there's also the not operator. So, you know, you can put not in front of everything. Relational question. So, it, you know, not is the Boolean opposite, right? Not true is false. Not false is true. Operator. And we'll see a few more. So here we go as we start. So let's just do a few things, and we'll say, you know, number equal 5. And then we'll say, I know it's messed up. Help me. If number greater than, you know, not 8, print number greater than 8. I know, and this is real boring messages. We'll get really cool later. Okay, here we go. And I'll run it. It says nothing happened. Right? It ran. It says that the number is 5, and you come along and you say, hey, is it bigger than 8? No. So this is the true case. So let's make it work. If the number is greater than 2, you say, number greater than 2, number is 5. Is 5 bigger than 2? Yes. Oh, I guess I should make the message correct. You say, well, that's kind of boring. So I'll just complicate it, and I'll basically copy this code. Just let me, there, finally. So that's the if case. So it asks the question if, and in here will be the true conditions. And you'll say, and I'll make it such that it's not just one statement. So it's the level of indentation that matters. So in other programming languages, you'll have something like this. So they'll have like some kind of tag that tells you to start something and to end something. Okay? And I'll make this other statement in here. Great. And I'll emphasize it with different quotes, single quotes here, just because it'll be different. So, this is what other languages will have. Python says, no, we don't need your we don't need your curly braces. So here it is. It's by level of indentation. Okay, so these two are at the same level. It's when you have more than one statement together, but a lot of languages call it a block of code. Yeah, these two statements are a block of code. They go together. Okay, great. That only happens if number is greater than 2. Sorry, let me put a greater than here. So I'm going to run it. So it ran both of those things. And I'll just print this thing at the end. Just, it's nice when you demo things or running code that you don't know what's happening. You know, it's nice to tell people, I somehow got to the bottom. That kind of stuff. Oh. Great. So it got this because 5 is bigger than 2. Okay. Same code. I copied it below here. I'm going to say, I'll keep the same code, less changing. I'll say greater than 2. Okay, I'll make it -3. Remember, okay, my 3 keys losing. Make it -4. So, you know, don't fear the negatives. And I'm just doing integers because it's easy. Less typing and I'm not doing any math. But you can say, hey, is number's -2, -4. You say, hey, is is -4 greater than 2? False. So it doesn't do the true block. All you'll see is this thing, because this statement is not indented. So the conditional is here and the block is here. So this is like one whole unit in itself. Okay? So if if the number is greater than 2, it'll have those 2 statements printed, whatever. And in addition to that, it will it'll always print out done, no matter what. Done will always come out because it's the level of indentation is at the top, Okay? Okay, great. Copy this code here. Put it here. Same code. We'll say nothing happened here. Okay. Just like you say, if you clean the dishes, I give you $5. That's pure incentive. That's pure true. If you do it. What if I don't? Nothing. I didn't say anything about it. If you don't. But, you could also say that. If you clean the dishes, I give you $5. Else, you're grounded for the night. So there's always the else condition. And we'll show you that right now. Well, the opposite of greater than 2. Does anyone want to tell me? What's that not greater than 2? Mathematically, what would you say?
Yeah, -4.
No, no minuses. This is all about 2. There's a thing that's 2. Is it bigger than 2? Then what's the opposite? If it isn't bigger than 2, what is it?
It is less than or equal to.
Oh, did you hear? Oh, thank you. Everyone just says, not everyone. A lot of people just say less than. Well, then what if it's equal to 2? So the opposite of greater than is less than or equal to.
Yeah, that's right.
So think, and also the other one too. What's the opposite of equal? Equal. Well, equal equals equality. Not equal. Right. But most people don't say not greater than. They say less than or equal to. So here we go. So this is the else condition. So here we go. Number is less than or equal 2. Equal to 2. I'm sorry. Comment? Oh, recording, Mo. Or, what is this one? Oh, I'll just say sorry. Okay. Just to show that there's more than one statement. Like less than equal to, yeah, this should work. And what happened? Well, the logic is yeah, you did the assignment, it's -4. Great. You asked the question, is -4 bigger than 2? False. Here's the true case. Here's the false case. Now stop writing true, false, but this is just to show you, okay? So the program flow says -4 bigger than 2. False. So it avoids the true one. It goes to the else, and it does that. The number is less than or equal to 2. That is correct. You know, the diagnostics or the print statements indicate what's really happening, so that's good. Any questions so far? Now, they don't have to compare numbers. You can compare strings and you can say, you know, here's one name, here's another name, and ultimately they'll say, is Ed greater than George? Yes, E occurs before G. So it'll sort. It doesn't sort. It'll compare like alphanumerically, and it does other things too. But so this is sometimes, like, a lot of people be the default. This would be like the fall through case. So let's do it again. What happened? Better now. Okay, great. Oh, I'll leave it there. Else if. You don't say else. You don't say ELSE space if. It'll yell you. You say elif, and so you say number is less than 2. You say greater than, less than. So number is less than 2. Great. Want to make the messages different. So if it's not greater than 2, oh, pretend they're all integers. Okay? Just pretend they're integers. Greater than 2. Okay, you got those. And then you got the less than 2. Well, then what's this one have to be? What's this fall through case, or the default case?
It means equal to.
Yes. Now you can ask it differently. It's just the way I asked it here. Equal to 2. Let's just run it, okay? So -4, you say, is -4 greater than 2? False. We're good, so you can still hear me, folks? Folks, can you hear me?
Yes.
Good.
Yes,
Okay.
we can hear you.
No, I had to mute something. I was wondering if I muted you guys. So this is not the case. -4 greater than 2. False. Then you come down to the next condition. So it's a sequence, and you can have else if, else if, else if, else if to now until kingdom come. So there's only one. You don't have to have one else if. You can have multiple. Okay, so we'll do that next. And what do you have here? Is a number less than 2? -4 is less than 2. That's right. You agree, right? So it says number is less than 2. about that. I declined. We're still back. We're still alive, right, folks? Can you hear me?
Yes, we can hear you.
Oh, great. Didn't kill it. So what is this? Well, did it? You agree? It did this one, this part right here. I'm trying to highlight it. That part right there. Okay. But now, what if we make it 2? Now, remember, the only reason I said about integers is because you should not compare equality on floating point numbers. Because 3.9999, because you did some math, and you're saying it's supposed to be 4, but it's floating point number that came out point 3.999999, and you say, hey, is that number that after you did the calculation equal to 4? And it says, no, false. And it's like, how can it not be 4? And you print it out, and it comes out 3.99999. Well, that is not equal to 4. So you do, in floating point numbers, you should not compare equality. You can compare greater than, less than. I would even avoid not equal. So don't do the equal or not equal thing. So you do what's called, you say, is it close? 3.99999 close to 4, down to 4 decimal places. That's an absolute compare. But you can also do a relative compare. So a relative comparison versus an absolute. Don't test equality because it'll work most of the time, and then there'll be some time where it doesn't because of the way internally it stores like floating point numbers. But integers are good. They're perfect. I mean, strings are perfect. Okay, you assign a first name to Stevie. There's no. It's stored. So we're going to say 2. So it's going to say, is 2 greater than 2? False. Is the number, meaning 2, less than 2? False. So it just falls through here. Great. And you can have this else if, but I'm going to move on. Good so far? Okay.
Yes.
And I'll say first name equal Harry. Yeah, Harry Potter, I guess. I don't know why. First name is Harry. Anybody know all the characters? What's the Harry Potter? Do they refer to their group of names as something? HP characters. Okay. Anybody know the name of some Harry Potter characters other than Harry?
Not Gandalf something?
Oh, okay. No, remember, we're gonna name it properly, so we're not gonna worry about weird things. Gandalf, Gandolf, got it. Snipe. I don't know if I'm spelling it right. Oh, come on. None of you guys have any more than this? Can't be that not Harry Potterish, right? Anybody know any more? Oh, this is sad. We shouldn't have picked these. Hermione. Hermione. Of course, I know this is wrong. Anyway. Right? And what's his best buddy? The guy with the orange head. Orange hair, I meant. Oh, we're not Harry Potter guys, so we're going with this, okay? HP characters. Got it, Harry Potter character. And you can say things like, and I'll just test equality, okay? So I'm going to just say this thing up here. Like, up here. You see this here? I could just do this, like, out of the clear blue. So you don't have to write all these conditional things. You can just say, hey, is number greater than 2? And that comes out to be Boolean, right? And then you say, well, because number right now is 2. And you say, well, what about if it's less? It is still false. It's like, how can a number be not bigger than 2, and well, not bigger than 2, not less than 2, because it's 2. So thank you for picking that up. So it is not, you can say what is a number, but you're writing a program. You don't not eyeballing. You say, is it equal to 2? And don't say equals. People will mess up. Equal is the equality testing. It's a relational operator, just like less than and things like that. It's a number equal to 2. You'll say it'll hopefully be, yeah, true, got it. So you can ask those questions and you see where the booleans come, okay? So here we go here. I'm going to just define it up here as a separate, it's the rectangular region is called a cell. So I'm going to say his first name, and this is what I would have to write. And we'll learn about this when we write a loop. Got it. Might get to loops today. If first name equal Harry, or so you can group these relational operators with logical operators, and are operators, and they're and or they're the big ones. Okay, they're the big ones. So we're going to say, is your first name Harry? Or instead of putting this on one line, I want to put this here. Oh, or. I'm going to cheat. I'm going to copy this like a maniac right here. Is first name Harry or Gandalf? And this is like, stop writing code like this. Snipe. Sad that we're not that on. Anyway, Hermione. That is me. I'm looking at the way I spelled it. Okay. Okay. If the first name is Harry, or if the first name is Gandalf, or the first name is Snipe, or the first name is Jaime, print. Okay, in the movies, in the movie, well, I guess it's the movie, in the movies, got it, end of story, okay? And it doesn't like this or thing, so you got to fix this up a bit, and this is when you need parentheses to group it, because these things can get involved. So you say that's a parenthesis, and I'm going to just there. I messed that up. Oh, yeah, it wants it on one line. So sometimes this will happen. And how do you tell it that, how do you tell Python to say, go across multiple lines? This is a line continuation character in Python. Oh. And it says you're in the movies. Well, who's in a movie? First name. It's like, well, first name, who's the first name? And because you're getting this first name from some programming thing is coming in live, somebody typed it in, it's like, can you tell me who that was? So you want to beef up your diagnostic or your print statements. You say, who was in the movies? Well, I don't know, whatever the first name is. Now remember, this is printing out the variable, the value behind first name. It's not printing out FIRST name. It's printing out, in our case, Harry. Okay, so I'll run it. Let's see, Harry in the movies. Oh yeah, right. So Harry is in the movies, right? And you say, well, can you also tell me who if you're not? Oh, yeah, okay, here we go. I'll just say else. Okay? Print first name is not in the movies. Okay, so Harry's in the movies. Okay? Everyone good so far? But now I spell Harry with a little h. Oh, I got to run it. And it says Harry is not, well, little h is not in the movies. That's true. Because it's case sensitive. So you can see here where it's doing this. Is it this? 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 What if there are 100 of these? This is getting crazy. So you can, yeah, it's called the membership operator, and in is used in loops. That's what the membership operator is called in. It's the word in, in, but it's also used in loops. So I want to make sure you understand what in does for you. So this is your introduction in membership operator. You say, this is craziness. This is crazy. So I'm going to copy it down here. And I'm going to say, if the first name is in, what was that called? HP characters, Harry Potter characters, okay? And it's a list. We can make it a set because no one's really changing these things. Not a set. Well, it could be a set because you know why? Well, what if there's two Harrys? Do you say Harry twice? You know, but they're different Harrys. You don't want to set. And how do you tell the difference between the two Harrys? Your name is Harry. Which Harry do you want to be in the set? You know, Harry number one. So, but you can make it a tuple. Why? Because you're not changing it. This is like a lookup. You know, while checking the dictionary, I'm not changing the dictionary. Like the dictionary you're looking up, paging through. Like if you know what that means. You're not changing the dictionary. So this is a tuple. So it's better. So, and also if you see tuple, like you and I will be clued in saying, no one's changing HP characters. Good. Yeah, that means no one is changing it. But you also, the order is there too, right? I don't know why Harry comes first and Gandalf comes second. The order doesn't matter. But here we go. So it's called HP characters. I went up there to find out what the variable name was. It's called HP characters. So here we go. If first name in HP characters. ACTERS. Let's run it. Harry's not in movies. Oh, little h. Yeah, they're not. Well, he's little h. Harry is not. So, and this will, okay, so remember, this is membership operators. Does anyone want to test another name? Just for fun? Here we go. So that's if, then, else's. But I just want to introduce you to loops because, it'll help you. So here we go. What was it called? First name. Now, this doesn't happen much in programming world. You don't prompt the person much. Really, you don't. You get the information from the data. You read it from somewhere. You get the system time. You don't ask for what's the time right now. No, you just get the system time. What is today? Thursday. No, you don't ask them. You somehow get the system time. Say, give me the day of the week that comes from that thing. So you rarely ask for the user input, but we're going to do it. Okay? So first name, I wanted to get from the user. How do I do it? It's called input. Now, you can just say input, and it's sitting there waiting for you to type, and it's kind of boring. It's nice to tell a person, please, I'm waiting for you to input something, and please, I want you to type in your favorite integer number. And so I'm going to say, oh, whatever. And I'm going to say, enter your name. Okay? That's it. Okay? Now I'm just going to warn you because of issues of time constraints here. When you input stuff, it's coming back to you as a string. Remember, if you don't want a string, you'll have to convert it to an int. Like, say, give me your favorite integer. And it comes back as a string, and you typed in 17. It comes back as, quote, 17, quote. It's a string. So what you have to do is you have to make it, well, you said int, so you got to make it what you want. You wanted an int. But when you get stuff, often, a lot times, it's when you get stuff from the outside, or you write stuff to the outside, it's coming in and out as strings. Not totally true, but roughly. So so we don't, it's coming in as a string. And here we go. I'm going to run it. It says enter your name, and I'll say George. Oh, whatever I spell Jorge, or that's not even how you spell Jorge. Anyway, here we go. And it says Jorge is not in the movies. Yeah, that's true. Okay, let's run this again. Go back here, run it again. And I say, Ed. Ed's not in the movies. Okay, well, not in those names, whatever, right? You know, I guess I could prompt, like, enter, and if I had all the characters of Harry Potter, and say, enter any name of any character in Harry Potter. And, you know, if you don't mention at least one of them, it's sad. But, you know, everyone knows Harry, right? Anyway, but all the other ones, it's like, what's that name? Oh, Weasley. Weasley is one of them, right? But still, how do you spell it? Anyway, enter your name. And I'll just say Gandalf. Gandalf is in the movies. And say, Ed, I'm getting tired of this. Can I just keep running this over and over again? Yeah, here comes loops. Okay? We're going to revisit this one and say, keep asking until you enter the word like stop. You enter stop, that means stop asking me. So, or what if I say, give me 3 names? And then it stops. So there's 2 big things I just said there. When you do repetition, meaning we're talking about loops now, if you know how many you're doing, how many loops or repetitions you're doing, that's called definite. Well, I call it definite, and you'll see it referred to that somehow, some places. And you say, well, yeah, that's like if you did calculus, it's called the definite integral, or even derivatives. You know where it's starting and you know where it's ending. You have definite boundaries on it. You know where its ends points are. So that's a definite loop. And that's what you'll have most of the time. You know how many times you got to go through. Somebody gave you a clue, okay? Or somebody told you where to start and where to end. Okay, you don't always have to start at 0, go to 10. You can say, start at 5, go to 15. Because that means something to somebody. You know, no, we have numbers coming from 5 to 15. No 4s, you know, no 17s. So just match whatever it is naturally. So that's called a definite loop. You know where you're starting, you know where you're ending. What if you don't? So that's an indefinite loop, and that's done differently. So let's do them, and we'll try to relate it to this thing up here, because I guess it's sort of entertaining, maybe. But we're not looping, 75 times, taking 75 names. No, I don't. That's here we go. Loops. So definite. No start, stop, roughly. Indefinite. Yeah, well, the opposite, right? Yeah. Here we go. So let's do the definite. The definite loops are for loops. So a lot of people just say for loops. Well, if you say for loops, you didn't get the other ones. You didn't get the indefinites. Okay? So So when people say for loops, that's like generic, because Python, for loops are the definites. The other ones are the indefinites or something else. So we'll just say this: for I, for index. And a lot of people use I's and J's for indexes. And I would say for index in. Oh. Well, let me back off here. And I'll just say, you'll be using this. So you'll say range 0 to, and it's a function. So you do comma, you don't do that colon thing. But you say, wait, that looks like a slice. Yeah, it does. So you say 0 to 8. I don't know why, just to be different. It says, oh, you got a range. Oh. What is that? What is that? No, I'm playing along here. So what is that? Uh-oh, wrong. What is that? Well, you'll say, give me the data type of it. You'll be doing this a lot, especially when it's like, find it. Oh, it's not a list. Oh, what is it? I got to make it a list or something. So first the question is, well, what is it? Because then you'll attack it, and it's called a range. What is it? Well, this is called a generator. It's really kind of cool. What if I said I want you to have numbers between 0 to 7 trillion in increments of 1. So it's going to be 0, 1, 2, 3, 4, 5 up to 7 trillion. Where does it put that stuff? Takes up memory. And he's saying, well, it's only an integer. That's true. But what if it were something big? I want 7 trillion of them. Well, it's this concept called generator. I'm only going to give you what you need when you ask for it. So when you say, give me something from 0 to 7 trillion, do you actually get 0, 1, 2, 3, 4, 5? You get nothing. You actually get nothing. Well, you get this object that's ready to get, it's called generate. It's ready to generate. And you keep saying, next, 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 next. But the loops will do that all for you. So you say, what's going on here? So you got to sit there and tell it, saying, you know what? If I were to look at it, what would it be? And most people just throw it into lists. You say, yeah, that's exactly right. Remember, it goes, it's 0 to 8 on the low side. Where it starts, it's inclusive, so it does include the low side. On the upper side, the right-hand side, the greater side, it doesn't, it infinitely gets close to 8, but doesn't. Okay, so it's 0, 1, 2, 5, 6, 7. Great. So we'll do this. We'll say range. We said 0 to 8. Oh, how did we say it? We said 0 to 8. But you don't have to say, there's a lot of defaults. So I'll just say 8. Okay, range 8. And I'll just say, okay, print index. You say 0, 1, 2, 5, 7. Yeah, I didn't have to specify it as 0. Now, most people don't say index. That's like too many words, too many letters, I should say. So you say I. You say same thing. Yeah, I is a local variable. When I come, it's not known to other. The scope is only here. So there's, and you can say any letter you can say Q if you want, but if you say that, then people have to stop and think. It's like there's ought to be a reason why they named it Q. No, not really. So don't throw people off. I is a good one. If you don't like I, you can say index or IDX or something, because index is important somewhere. So you can't use the word index because somebody else has it or something. So there it is. 1, 2, 3, and so print statement. If you haven't figured it out, print will do what it says, what's ever in the parentheses, and then give me a new line. Any questions so far? So that's doing something 8 times. 0 to 1, 2, 3, 4, 5, 7, right? That's 8 times. But here we go. I'm going to copy this. I'm going to throw it in here. And I'm going to only ask 3 times. And what am I going to ask? Oh, I typed a 3, but it didn't work. What am I keying? Oh, this. right here. There we go. So remember, the level of indentation tells you what's going on. So it's doing the it's doing this thing. If I had a 3 in there, it would make sense. There, finally. So it's going to say, it's going to do all of these things with I equals 0. Then it's going to come around and it's going to do the same blue parts for I equal to 2. And then it's going to do the same blue parts for I equal to 2. So 0, 1, 2. Okay? And remember, just to convince yourself, it's always nice to, well, when you're learning, I guess, something out there to tell that, you know, you're outside the loop. Great. Now I'm going to run, okay? Yeah, that print statement would be a little weird, but who cares? Let's say 0, whatever that means. Okay, enter your name. Okay, Ed. Or Danny. Danny's not in the movie. Now we're down to 1. Now we're in the first, well, 0, 1. Now we're going again. And we'll say, I can't spell Hermione. I can spell Gandalf. Gandalf is in the movies. Okay? Then I'll say Stevie. Now, which is Steve's not in the movie, then it's done. Wait, that's definite. I know I'm only going to ask you 3 times. Okay? So, this is with numbers, with indexes. So, this is like a counter thing. I'm going to do something 3 times. Yeah, this is the way to do it. Don't do that if the thing coming down, you know, with an indefinite loop, and then you have to make a counter, and you got to keep track of it, and then you got to test it, and then you got to break out of the loop. It's like, yeah, but will it work? Well, I can make an indefinite loop here, too. I could say, do it infinite amount of times. I could do the equivalent up here, saying infinity. Don't be crazy. No one does it. So there's this other 4 thing. So there's HP characters. So I'm gonna just print it. You say, hey, there's looks like 4. Great. Can I iterate through this? Yes. So here we go. We're going to do it the old-fashioned way. You know, people doing this like, you know, earlier, in the, you know, early 1980s. So there's terms for this. So for I in, how do I get that 4 thing? I want to get the length of this. How do I do that? Anybody remember? I want to print out Harry. I want to go through the list of HP characters one at a time. I don't know how long it is. I should not hard code 4, the number 4. But the length is 4. I know it's 4, but this list is coming in from nowhere, and it's like, I don't know where it is. Sometimes it's 7, sometimes it's 73, sometimes it's empty list. So how do I know how many elements are in that list? Anybody remember? Anybody remember?
Is it adding the count function at the end of the tuple?
Stop. Well, everything except that count word is perfect. You got the tuple part right. This is funny. So, you know, it's something, but it ain't the count. It's a len, right? Remember? The len is 4. You agree? Oh, do you agree? Hopefully. That is 4, right? If I deleted something, it would be 3. If I added something, it would be 5. Great. But stop coding 4. So I would want to say this, wouldn't I? I would say range of 4. Please don't do that. You know, it's very select. I mean, what if someone changes something? Then it's going to not work. So you should say the range of the length. So it's going to do the length of whatever I did up above, and it's going to come back with 4. And then it's going to do the range of 4. CHARACTERS. Got it. Okay? And just to convince yourself it's going to work, and this is what I typically do because sometimes this gets really exotic with advanced stuff. And well, actually, the first thing is like, is it even starting and ending where I think it is? And I just say, okay, well, first statement, am I even in the ballpark? Am I in the right place? And it says, what's going on?
Letter C.
Yeah, thank you. And and you say 0, 1, 2, 3. It's like, that's not what I wanted. Anybody have a hint? You know stuff from yesterday, mostly. Well, the previous session. I don't want the number. I wanted to say Harry, and then Gandalf, then Snipe, and then Hermione. Does anyone know what I should be doing?
Should be correct. That's...
What's that?
So we need to print the name. So we have to give HP characters.
Very good. What about it? And I'll print this out just to. You'll probably never do it, but if it ever happens, it's printing the same list 4 times. Not
4 times.
quite. What do you want? You're real close. You're in. What's that?
Unique something or
no? You
distinct?
want to say, I want to get to HP characters, but I want to say the 0th one, the first one. Every time. So you index into it. So you say whatever the index is. It's called I. Right there it is. You agree?
Yeah.
They said, Ed, I don't believe you. Well, enhance it. Print I and followed by the ith character. Right? You're saying the 0th character is Harry. This is the first character is Gandalf. You say, yeah, that's kind of cool. So this is the old-fashioned way, and it still works. There are times, okay, there's a general motto. If you see range len, you better justify why you're doing it, because it's not cool for a lot of reasons. But it's the old-fashioned way. It'll work. If you're coming from that programming environment from the 1980s, you're still okay. But there's better ways to do it. So here we go. Here's a better way to do it. For something in HP characters. Okay, 2 minutes, Mo. So here we go. And we'll say name. In. Got it? And we'll stop here. Well, a minute or two. Saying success. A lot more modern, more Pythonic. So this is, all languages, including human language, have these things called idioms. And the idiom is such that it makes it more natural. So in a programming environment, they have idioms also. So it's more like the language. This is Python, so it's called Pythonic. So this code is very Pythonic, which is a compliment. I don't see indexes, and you're just giving it this arbitrary thing. You're just saying you can call it anything. You can call it for Q, print Q, and it goes to whatever this is, like one at a time. Now these could be numbers, and then you can say do whatever number you have times 2 for whatever reason. But remember, we have strings, so we're going to stop. And we'll pick up the infinite loop tomorrow. Well, I said infinite, didn't it? The indefinite loop. So how do I make it keep going? Keep doing whatever you keep doing until you see what's called a sentinel. Keep going until you see this. That's a signal. A sentinel is like a train thing. It's a signal to stop. So you keep going until you see a sentinel. Okay? So we're going to stop, folks. Sorry I don't have time, but I'm going to have to stop. Okay? So I'll see you tomorrow, folks. Adios.
Thank you.